2.2, we're going to evaluate polynomial functions. So the first thing I want to do is review and remind you, raise your hand if you can tell me what is a polynomial function. Well, what's poly mean?
Many sides.
Many. The nomials, well,
Terms.
is the term. Okay, so we have many terms. So that's what the word means.
Function with a lot of terms.
Okay. Now, in polynomials I gave you another definition. You may not remember this. What did I tell you had to be true of the exponents in a polynomial? Anybody remember?
Nope.
They are always positive.
They can never be a fact.
And they're never fractions. They're always positive integers. Okay, so that's what we're talking about works for polynomials. So we're going to evaluate a function using direct substitution. This is what you've done many times before. I have a function, its name is f of x equals 2x to the 4th minus 5x to the 3rd minus 4x plus 8. I want to evaluate it when x equals 3. So I take f of 3. Now remember, this is not f times 3. This tells me when I'm evaluating the function at. So I'm evaluating at 3. So f of 3 equals 2 times 3 to the 4th minus 5 times 3 to the 3rd minus 4 times 3 plus 8. Okay. So let's do the exponents first. Order of operations, what's 3 to the 4th? Anybody?
81.
81. Okay, sorry I didn't catch it first. 2 minus 81. Okay, 5 times 2 times 81. Minus 5. 3 to the 3rd, what's that one?
20.
5 times 27. Okay, minus 4 times 3 plus 8. So we did our exponents. Now let's do our multiplication. 2 times 81.
Something with the 2.
162. 5 times 27.
135.
Okay, 4 times 3.
I got this. 12.
Oh. Plus 8. Okay, now we're going to add them. And let's see if I can be a little bit tricky about adding here. I got 162 and I got a negative 12. If I put those together, that's 150. 150 minus 135.
15.
15 plus 8.
20.
23. Okay, so everybody knows how to do that, right? You've done that before lots of times. Make sure you follow your order of operations. Okay, that is the method called direct substitution of evaluating a function. We're going to look at another way to do it as well. It's called synthetic substitution. And it's very closely related to what we did yesterday. In fact, we're going to use that. So I'm evaluating this function when x equals 3. So I'm going to set up my synthetic substitution just like I did before. I'm going to put a 3 here. And then across here, I'm going to do my my coefficients. So I have 2x to the 4th. I have negative 5x to the 3rd. I don't have an x squared, so I have to put a 0 in for that. I have an x, so it's minus 4, and then my constant is 8. Okay, draw your line. So I bring down my 2. 3 times 2 is 6. Negative 5 plus 6, it's a 1. And I take 3 times 1. Gives me 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 4 plus 9 is 5. 3 times 5 is 15. 8 plus 15 is 20. your remainder is not coincidence. Your remainder, when you do synthetic division, is going to be the value of the function at that point. We call it synthetic substitution. Okay? We're going to look in a minute at why that is, but I'm going to just do one more example, a couple more examples of these so we make sure everybody's on the same page. Any questions before I move on?
So it's just number 23 is just stuff like this.
So yes, so you would write the solution to this way. I would say f of 3, or the function evaluated at 3 equals 23.
Would we be marked off, we just put x equals 23?
X is not 23. Yes, you would.
Oh wait, because 3 replaces x. So we can't say, no, never mind.
I want you to write it that way.
F.
I want you to put f of 3 equals 23.
Not just 23.
Not
Forget
just
the
23.
second parenthesis.
Okay. Just do it right. Okay. The reason that we use this type of notation, and I know you guys aren't as comfortable with this, but you need to get that way. The reason we use this, if you look, I know both what my x value is and what my y value is by just looking at that statement right there. If I just had y equals, I don't know what x was. So this tells you more information. That's why we use this notation. Okay, so yes, I do want you to be using that. Okay, so let's do the same thing. We're going to do our synthetic substitution with a couple more. So I've got x equals 2. So I want to substitute that into 5x to the third plus 3x squared minus x plus 7. So I've got 5, 3, negative 1, 7. Double check, make sure I didn't miss any terms. There's no zeros I have to put in. Okay, bring down the 5. 2 times 5 is 10. 10 plus 3 is 13. 2 times 13 is 26. Negative 1 plus 26 is 25. 2 times 25 is 50. 5 plus 7 is 57. So, I would say f of 2 equals 57.
Okay.
One more. We'll do negative 1. So negative 1. And remember, x equals the number. You don't have to switch any signs when you're given what x equals. So we do the same one. 5, 3, negative 1, 7. Bring down the 5. Negative 1 times 5 is negative 5. 3 plus negative 5 is negative 2. Negative 1 times negative 2 is 2. Negative 1 plus 2 is 1. Negative 1 times 1 is negative 1. 7 minus 1 is 6. So we say f of negative 1 equals 6. Okay, so everybody pretty comfortable with that? Now, the one more thing I want to do is show you why it works. Now, I'm not going to scare you to death, so you do not have to write this all out. I have a long division problem set up. I have x to the third plus 2x squared minus 13x plus 1, and I divide it by x minus 4. And I get x squared plus 6x plus 11 plus 45 over x minus 4. Okay, so you guys know the process. You did it and complained about it, but everybody kind of got it? Okay. So if I do the long division, that's what it looks like. If I do the shortcut, this is what it looks like. And I get this remainder of 45. But what does it really mean? Here's what it does. See if I evaluate, let's evaluate this and see if it agrees with that 45. F of 4, okay, what's 4 to the third? 64. 2 times 4 squared, okay, minus 13 times 4 plus 1. Okay, then do the multiplication. So I have 64 plus 32 plus 13 times.
52.
What is it?
52.
52 minus 52 plus 1. So let's see if we add those. 32 minus 52 is negative 20. Negative 20 plus 64 is 44 plus 1 is 45. So it does come out the same. Here's what it does. When you do that division, I had this divided by x minus 4. So it tells me x minus 4 times my answer plus 45 equals my original equation. That's what division does, right? But here, look what happens if I substitute 4 into this. I get 4 squared plus 6 times 4 plus 11 times 4 minus 4 plus 45.
It's supposed to be 6.
Yeah, it is.
Yeah.
Actually,
6. There we go. Okay. I'm focusing not on this part. What is this factor equal to?
0.
If I take 0 times whatever that is,
Yeah.
what do I get? 0. So this would be 0 plus the remainder of 45, or just 45. And that's why it works. Okay, so your remainder when you divide by x minus whatever number you're evaluating it at is always the value of the function, which is a nice, interesting result, and it makes life easier for us. So that is